So hello everyone, today we're gonna discuss lecture number 2, that is capacitance of parallel plate capacitor in vacuum. So first of all, as in the last video I taught you what is capacitor and capacitance. So here capacitance is basically the ratio between charges stored on a plate and potential difference across the plate. Ratio between charges stored stored on a plate capacitor across the conduct potential difference. Okay, after that here what is capacitor? So capacitor is basically it is a device that is used to store a large amount of electric charge. Device used to store large amount of electric charge. Sorry. Okay. So here first of all here I'm gonna draw the you can say circuit through which we can understand the capacitance of parallel plate capacitor in vacuum. Okay. Oh my god, sorry. Here we have positive charges. Here we have negative charges. The field is always from positive to negative, and this place between two charges is vacuum, or we can say air. Okay. So here we're gonna discuss about that. For example, consider two opposite charges. For example, here we have considered two opposite charges on parallel plate. These are what? These are two parallel plates. Okay. These are two parallel plates on which we consider two opposite charges. One was positive, another was negative. Okay, after that they are saying reported by small distance d, means these both charges are separated by small distance, the small distances d, and the small distance d, positive plate of capacitor connect to positive plate of the capacitor, and the positive plate is connected to the positive plate capacitor, and negative is connected to the negative plate capacitor, and battery stored charges. Okay, after that here we have what, as we have discussed that charges are basically directly proportional to potential difference. जितना हम यहाँ से potential difference provide करते जाएंगे, charges की ability ज़्यादा होगी क्या करने की, store करने की. Okay, so Q is equal to KV, oh sorry, CV. C is the capacitance and constant. CV, C is equal to Q over V. Okay, here we got the first equation of capacitance, that is what? Capacitance is basically the ratio between the charges of the conductor and potential difference across the conductor. After that here we have, now we know that हमें पता है कि that here charges always have what? Charges always have charge density. They always have charge density. Okay, charge density, and charge density is denoted by sigma. So sigma is equal to, we can say, Q over A. Charge density is basically charge per unit area. Remember this charge density, this is what charge density, which is charges per area. Okay, after that here we have, now we have to find the charges formula. So Q is equal to charge multiply charge density area. Area is divided, there will go multiply. So we got the Q. So this is what this is, as I told you, this is charge density. Okay. Now here this Q we are putting in the this first equation. Q, the value of Q we are putting in the first equation. Putting the value of Q in first equation. What was first equation? That was C is equal to Q over V. Okay. After that here we're gonna put the value of Q, so that is Q is equal to charge density area upon voltages. Q is equal to charge density area over voltages. Now we know that हमें पता है कि potential difference is equal to what? Potential difference क्या होता है? Work done per unit charge. And other formula of potential difference is, it is basically the dot product of electric field and potential difference. Dot product of electric field and potential difference. So here we're gonna use the electric field and potential difference, this one formula. So let's put the formula of V in this equation. In this equation, okay, this is for suppose third equation. So let's putting value of V in equation number 3. So what is equation? C is equal to charge density area over what is the value of V, that is electric field per potential difference. Okay, so here what we get, this is basically the final we can say fourth one equation. Now we know that हमें पता है कि this is electric field intensity, sorry. We know that electric field intensity is what Newton per coulomb, and other formula is force per unit charge. So this is unit. Let me remove this so you will get confused. The formula is force per unit charge, and other is kq over r square, or charge density over charge density over relative permittivity over permittivity. So for suppose here we know that we have charge density permittivity is gonna explain in this, so we're gonna use this one formula. Okay, so this one formula, so let's put this formula over here. C is equal to charge density area over charge upon epsilon dot d. Okay, this I put the value of E, electric field intensity. Fine. After that, when we cut this, we will get what? C is equal to area upon 1 over epsilon d. Now epsilon is divided, it will go and here it will multiply. C is equal to epsilon A over D. Epsilon A over D. So this is the final equation, which is in the vacuum capacitance of the parallel plate capacitor in the vacuum. The formula is this: electric field intensity A per electric field intensity into area per distance. Okay. After that, here what we are getting, that this capacitance in the vacuum is basically directly proportional to area and inversely proportional to distance. Okay, directly proportional to area and inversely proportional to distance. Here the one main thing is also that if the dielectric is placed between the capacitor, क्या अगर दो पैरेलल प्लेट कैपेसिटर्स हैं, इसके बीच में अगर हमने वो वैक्यूम में बात की है, if we are putting the dielectric between these, अगर हम dielectric रखते हैं, so the we can say plate of the capacitor increased by ER time, increased by relative permittivity ER times. मतलब इसकी चार्जेस स्टोर करने की एबिलिटी ज़्यादा हो जाएगी, बढ़ जाएगी इफ़ यू आर पुटिंग द डाइलेक्ट्रिक बिटवीन टू प्लेट्स। ओके, और कितनी बढ़ेगी? बाय ईआर टाइम। जितना हमारा ईआर रिलेटिव परमिटिविटी बढ़ेगा उतनी ये इसकी चार्ज करने की कैपेसिटी बढ़ जाएगी। सो दिस वाज ऑल अबाउट कैपेसिटेंस of parallel plate capacitor in the vacuum. In the next video we're gonna discuss about capacitance of parallel plate capacitor in dielectric while placing dielectric. Bye bye.